Hey everyone, so this video is just going to kind of take everything from the 4.2 task and tie it all together and just make sure that you've got some good notes on the different things that we were trying to accomplish in the 4.2 task. So this first part here is taken directly from the task. We've got Elvira, the cafeteria manager. She's got her different symbols here where she's recording the number of things and different other quantities in the cafeteria. So we can see the first three are the number of lunches sold in the salad line, sandwich line, and pizza line. So the thing that we're measuring here is just our units. P is where it starts to get a little more interesting, right? P is the price per lunch. So that word per should be a clue to you that we're talking about a rate. And so if we look, our units look a little different. Our units now are dollars over lunch or dollars per lunch because we're talking about a rate. And we know that a rate is going to end up having these units that look like a fraction. Then when we look at the M, it says the number of minutes it takes to prepare each lunch. That word each is also a clue to us that we're going to be talking about a rate. And so our units here are now minutes per lunch or minutes over lunch. And then the last thing we're looking at is the number of classes in the school. So the thing we're measuring is the classes. So if we take a look at part 1 here, it says create an expression using the variables defined in the table. After you write the expression, determine the units of the answer. So we need some type of expression that tells us the total number of lunches served. If we think about it, in order to determine the number of lunches that were served, we should probably know the number of salads, the number of sandwiches, and the number of pizzas. So when we think about it, number of salads sold plus the number of sandwiches sold plus the number of pizza lunches sold should give us the total number of lunches served, because that's the only thing that we're serving in the lunch lines. So if we think about it, the number of salads sold is represented with S. So when we start to actually write this expression, instead of writing words, because that gets annoying and we're mathematicians, we're going to be lazy, the number of salads can actually just be represented with the symbol S. The number of sandwiches sold can just be represented with W. And the number of pizzas sold can be represented with Z. So this is actually the expression that we're going to be looking at. S plus W plus Z is going to tell us the total number of lunches served. Now if we think about the units that go along with that, the number of salads sold, the units there was just lunches. In terms of the number of sandwiches, if we look at that, W, the units we chose, or that we said we were using, was lunches. So we've got lunches, plus, for Z, it's the same idea. We're doing number of lunches. Which means if we do lunches plus lunches plus lunches, we're going to have an overall unit of lunches at the end. So whatever we end up getting when we do S plus W plus Z, the overall answer then is going to have the units of lunches, which makes sense. We're creating an expression for the total number of lunches. So that matches what they even told us in the original sentence. Okay? Let's do one more. Create an expression for the total amount of money earned by selling pizzas. So total amount of money earned by selling pizzas. We need to think about the things that we would need in order to figure this out. To figure out how much money I earned, I'm going to definitely need to know the price, right? So the price per lunch lunch. I can spell, don't worry guys. The price per lunch. And I'm also, since I'm looking at how much money I earned by selling pizzas, I probably need to know how many pizzas I sold. So I'm going to need to know the number of lunches sold in the pizza line. In order to get the actual amount of money that I made, I know I need to multiply those two quantities. So let's think about actually being able to write the expression for this. So if we think about the price per lunch, we know that the price per lunch is represented with P. So we're going to do P times the number of pizzas sold in the pizza line is going to be Z. So this is going to be P times Z. You could write that also, if you want, as ZP. You could write Z times P. You could write PZ. All four of those things are going to end up meaning the same thing. You don't have to have the dot in between. It just helps show that the multiplication is there. So whatever works best for you. And if we wrote these in a different order, if we wrote them backwards, that's how we would get to ZP. Let's look at the units that go along with that then. So the units that we're looking at here, if we think about the price per lunch, P was measured in dollars per lunch. So dollars per lunch times Z, which if we look back up here, Z is the number of lunches sold in the pizza line, and the units there were lunches. So we've got dollars per lunch times lunches. And if we look at that, the lunches end up canceling each other out, and we're left with overall units of just simply dollars. Look back at the expression they asked us to create. It said create an expression for the total amount of money earned by selling pizza. Well, we came up with the units being dollars. That makes sense. If we're looking at the total amount of money earned, we're going to need to know how much money that is, and we always measure that in dollars. So that's going to be our overall units right there. When we talk about that total amount of money, we know it should be in dollars. Okay, now we're going to go the other way. So now, if I give you these expressions, can you tell me in words what they mean? So these are the same variables and units from the page before. We've got SP in this first expression here. So the first thing I want to talk about is, what does that even mean? We know that S actually stands for the number of salads sold. And we know that P stands for the price per lunch. So this has something to do with salads and money. We don't know exactly what yet. So let's actually think through the units that would go along with this, because that's going to help us figure out what we're actually supposed to have here. So if we look at the units associated with this expression, we know that the number of salads, which was S, has units of lunches. And we know that the price per lunch, that was P, has the units of dollars per lunch. And if we think about it, this really says lunches times dollars divided by lunch, which means the lunches end up canceling, and we have overall units of dollars. This looks a lot like the example we actually just did, where we were able to cross off the lunches and we were left with the dollars. So when we look at this, we know that this quantity here is going to be measured in dollars. And what are we really measuring? We're measuring something to do with the salads. So we know that if we take the number of salads and multiply by the price, that's going to actually give us the amount of money in dollars, because those were our units. So we're talking about the amount of money in dollars earned from selling salads. So again, we had to first look at what are these quantities, look at the units to help us figure out exactly what it is we're measuring. And so we know, since we got down to dollars, we're talking about the amount of money that we actually made. And how did we make that money? We earned it by selling salads because that's what the S stood for. It told us how many salads we actually sold. Okay, one more. So take a look at this expression. We've got M times the quantity, S plus W plus Z. That S plus W plus Z should look pretty familiar because we actually wrote it in part 1. So S, W, and Z are the number of lunches in the salad, sandwich, and pizza lines all together, which means if we add those 3 quantities up, that's really just the total number of lunches sold. And then if we think about what M stands for the number of minutes it takes to prepare each lunch. So this is the number of minutes per lunch. So let's take a look at those units. Number of minutes per lunch, that was actually our units right there, right? So that was minutes per lunch times the total number of lunches sold. Well, the units on that was lunches. And so we get that the lunches cancel out. We're left with an overall unit of minutes. So if we think about it, we're talking about minutes, and we talked about the total number of lunches sold. That means this expression must be telling us the amount of time in minutes to prepare all the lunches. So examples 3 and 4, we're doing the exact opposite of what we did in questions 1 and 2. So you'll notice the sentences that we wrote pretty much match the sentences that were written in questions 1 and 2. Different scenarios, of course, but the same idea. Okay, there's one more thing from section 4.2 that we need to talk about. The last thing we need to talk about is solving literal equations. I want you guys really quickly to circle the word solve. And when you see the word solve, I need you to think about inverse operations. When we're solving equations, that is the only time that we're allowed to use inverse operations. So all of these, let's see, number 5, we're asked to solve for x. So what I like to do is I like to highlight the x that I am looking for, because when I look here, I can see that there's more than one variable. And we don't usually solve things that look like that. So I need to highlight the x because that is the thing that I need to get by itself. Right now it says 2 times x. So I know in order to solve this equation, I'm going to need to use the inverse operations. So since it's 2 times x, the way for me to solve that is going to be to divide by 2. And I know if I divide by 2 on one side of the equal sign, I have to divide by 2 on the other side because I have to keep it balanced. And when I do that, these 2's cancel each other. So I get 10y minus 3 all divided by 2, and that's equal to x. Now there's nothing I can do on the left side here because there's no like terms. There's nothing for me to distribute. And even if I try to divide, I'm going to end up getting a fraction still. So I'm actually just going to leave it alone because I got the x by itself and I did what I was supposed to. Let's take a look at number 6. For number 6, it says solve for b. So if I look, b is right here in my equation. When I look at the b, it's not completely by itself because it's got this minus h along with it. So in order to get rid of that minus h, I'm going to use the inverse operation. So instead of subtracting, I'm going to add. So if I add h to both sides, that will cancel out on the right side. And I get b on the right. Over here, I have a plus h. I don't know what that is because I don't know what a is and I don't know what h is. So there's no putting it together. I'm just going to rewrite it and then I'm done. Number 7 is a little bit more complicated. Number 7, we're solving for x, and there is a lot going on here. If we look at that x, it's going to take us a little bit to be able to solve for it. So right now it says 2x minus a divided by b. Well, the last thing that's happening there is the dividing by b. So that needs to be the first thing that I undo using my inverse operations. So that means to get rid of dividing by b, I'm going to multiply by b on both sides of the equation. When I do that, on the left, I now have 2x minus a equals w times b. And there's nothing I can do with that w times b. I could just write it as wb. Now, I'm still solving for x, and it's not alone yet, which means the next thing I'm going to have to do, right now it says 2x minus a. I need to get rid of this subtracting a. The way to do that would be to add a on both sides so that it'll cancel. So now I'm left with 2x equals wb plus a. Now I'm getting closer to having x by itself, but it's still not quite alone. Right now I still have 2 times x, so the way to get rid of that 2 is going to be to divide everything by 2, so that the 2 will cancel out, and I'll be left with x equals wb plus a all over 2. And that is our final answer for that one. I know that this was a lot in a video, you guys, and I know that this can be kind of confusing, so please make sure that you wrote down any questions that you have so that you can ask your Math 1 teacher in class when you see them, and you can get some help and make sure that you will be ready for our upcoming 4B test. Have a great weekend. I will see you guys later. Thanks for watching.